All right, today we're going to be talking about cross-origin resource sharing, or CORS as I'm going to be calling it in the rest of the video. This is going to be a little bit shorter, and I kind of, at least in my head, link this together with a lot of other browser type of vulnerabilities like cross-site scripting and cross-site request forgery, because just to me, like that's where it fits, and that's where I feel like you'll run into this the most times, especially in the lab scenario that we're going to talk about today. But let's just talk about what it is first, so it makes a little more sense. But it's a browser mechanism that lets controlled access to resources located outside of an original domain. And what that means is, instead of just using like a same origin policy or content security policy that's really restrictive, you have a little bit more freedom with how you're interacting with other domains. And obviously, the reason for this is so that websites can't attack each other to an extent. And it's kind of meant it's like a countermeasure to like websites hosting like malicious information that could be crossed over. But in some cases, this does open the door for, cross-domain attacks. And this is mostly because of like misconfigurations. So without any further ado, let's just go ahead and start talking about it. The precursor to like CORS and like the access control implementations is like the same origin policy. So it's meant to stop websites from attacking each other. It uses a URI scheme, which is comprised of like a domain, a port number, and a URI, and that's basically it. So like the scheme here, like if I set my same origin policy to example.com or http://example.com something, it would be like, yeah, you have access because, or if, my origin for my request says this, it would be like, yeah, the scheme, domain, and port match the one that we have. If it's a URL, in this case with just a different endpoint, yep, the scheme, the HTTP, domain, port 80, whatever, and the port are all the same. That's still fine. This one wouldn't work because it's using HTTPS, which would be a different port. So you can already kind of start to see the limitations. Same with this, it's a different domain, but it's a subdomain, kind of counts, but not really. And then, if you have port 8080, as a web developer, you might want to have like a Redis server or something running, in the stack that you can send requests to in a simple way like this. So you can already kind of see like where the limitations of the same origin policy are starting to set in. And, this matters because it's like if a browser sends a request from one origin to another, authentication cookies and information might be sent as part of that request to another origin, and that might be bad if it's a malicious website. So you want to have some kind of way of distinguishing between where this information is allowed to go, and where that kind of leads us to is the access control allow origin header, or the ACAO header, whatever you want to call it. And there's variations of this, but basically, if I was sending something from origin beta.com and I'm sending something to the data endpoint on alpha.com, it might reply with something like this: access control allow origin beta.com. So in this case, beta.com is permitted as an origin for the request, meaning that I'm allowed to at least request information from that site. It's allowed to get information from my site. We can kind of look at some misconfigurations or certain types of interesting thing about it. Or actually, before we talk about this, I want to finish this up. So what this is doing, because I felt like my explanation wasn't that good. So the browser will allow code that's running on beta.com to access this response that's here. So if there's a bunch of data in here, because this access control allows origin is allowing beta.com, it can then access details that are in this response. And, this is the browser protection. So it's not like some, clandestine thing that's operating at the packet level that you have no idea about. You can actually see this data in your browser. And we'll talk about that when we go through the lab. But because of this, and, there's vulnerabilities too, because there's a lot of misconfigurations you can make with this. If you permit it to read credentials like this with access control, allow credentials true, then, you can include authentication data, which by default isn't supported, but adding this additional header will. So there's other things, right? There could be parsing errors with how you're actually parsing in these requests and responding to them in your programming. You might also have the null origin whitelisted, which would basically just let any kind of origin work. Same with the wildcard origin. If somebody specifies a wildcard origin, they could then use that to I want to describe it. They could use the wildcard origin to, they would just throw that in their GET request and they'd be able to send requests back and forth and read those responses. You could also, there's other examples that I won't get into today, but making a proxy with cross-origin resource sharing or kind of downgrading from HTTPS to HTTP. Those are two things that I saw a lot of interesting details about that we won't get into today, but those are just kind of little things you can piggyback off of. But, messing with the configuration itself isn't necessarily like by itself that huge of a deal. Normally you would kind of link this together with, some kind of, you'd want to have it execute like JavaScript on your web server or something, and then read this, construct the response and then read it. And we'll go over that in a lot more detail in our lab. So Derailed is a pretty cool, insane machine that I wasn't able to complete when I first tried it, what feels like almost a year ago. But, there's like some WebAssembly with this stuff that you don't necessarily have to get into, but we'll just go ahead and get started with this, and then we'll come back and talk about prevention. All right, so I've gone ahead and just pulled up the Derailed machine on Hack the Box. We can run a port scan, and you see that port 3000 is open, and it's running this website called ClipNote. We can do something like test, and you can see it makes a new clip note. There's an author field, which is like guest. It has like a timestamp for the creation date. And what's really interesting about this is, there's some weird stuff going on over here, but you can see like we can view like the raw content, which looks like JSON, which is kind of interesting. So we can see there's also like the post ID that I kind of missed on the first one. We can also look at, this lets us download it as a text file, which I'm trying to open it. Okay, that's kind of neat. You can copy it to your clipboard, and you can also report these things. So please tell us why the clip note is appropriate, and we'll have and why it should be removed. Please remove. And then they tell us that it's been reported and an admin will have a look at it. CTF wise, if they say that an admin is going to look at it, you might want to start thinking about cross-site scripting. Now, that being said, you can try a variety of different payloads in here. And it's kind of difficult to get anything to work, or at least in my experience. There's a few different things we can try to look at. Like if I look here, you can see a simple Rails session. The name for this cookie kind of indicates that this is Ruby on Rails, and so is the name of the machine, right? Derailed. But that by itself, like, isn't, it's not super interesting. You can try a bunch of different payloads. First, let me just make an account here real quick. So we'll just do Gabe password, and I'm just going to capture this in Burp Suite in case, because I think we'll need this later. Let me just turn that on. Send this to the repeater. Forward it. Forward that login to, and then we'll just do. Whoops. Let me go ahead and turn this off. So now that we're logged in, you can see the clipnote ID incremented by 1. And you can also see that, even though we've got this like testing thing here, you can try a lot of cross-site scripting stuff. I wasn't able to get anything out of this. Also, it's kind of hard to get anything out of the username field. And this is where you might want to actually start like poking around a little bit more in the web application. We know that we can report, something and maybe get this clip note page itself viewed by an administrator. But even though you can try like cross-site scripting payloads here, I wasn't really able to get any of them to work. So what I might show you is just, oh wait, there's a command palette. Oh, that's interesting. That's cool. Anyway, what we'll go ahead and do is I'm just going to inspect the page. I'll go to the debugger, look at some JavaScript here, and I think clip notes might be it. This is the WebAssembly stuff. Let me refresh this so you can see it. You could debug this WebAssembly and use it to help with the step. I don't really know how to do that, and I didn't know how to do it when I tried it the first time, like a year ago. I still don't know how to do it, but not to say it's a bad idea, but it's also just not like vitally necessary for this. What I'm gonna do, I think, actually, let's try this. Let's go back to that registration page, because I think this is where we're gonna see it. Maybe I already missed it. forget what it's called. It might be clipnotes.js. Or maybe it's actually in the page source. Or yeah, it is going to be here. So after, I try doing stuff with the username. I try doing stuff with the, you can input cross-site scripting vectors into the username. You can do it into the page source. The only other, input that we can kind of control is the, that timestamp, but we're not really in control of that. And you might just try to write it off. But the thing is, there's something somewhere in here. Goodness, did I already scroll past it? I must have. You can see there's an authenticity token. We'll need this later for sending requests. But let me see if I can find it here. There should be like... Here we go. This is what we're looking for. So let me zoom in. Maybe it'll be easier to see. So what you'll notice is when putting in a username, we have a max length that's declared at 40, which is... interesting why they would have a max length like declared in the page source, and that this is how they're actually doing it. And then, as we noticed right in those clip notes, can I go back enough? Yeah, you can see we've got the name and then created 2023, December 5th, timestamp, pretty straightforward stuff. But we might be able to take this a step further and just see how harsh this limit is. So what I'm going to do is just create an account. And I've still got this here. Or wait, is this? Yeah, this is register. Okay. Let's do username. I think I'm just going to use the pattern generator. I think it's a user share. Yeah, I've got it here. Let's do length. Like we know that the max length should be 50. Or should be 40. Let's try 50 and see what happens. So this will generate something that's 50 characters long. And then we can just swap this out for the name. Looks like that made it just fine. I'll log out, log in. Here's our username. And we can make a clip note. And you'll notice something interesting right off the bat here, right? The username exceeds 40 characters and then passes over to this timestamp. So all of a sudden, right, there's another spot in this application, a sync. I'm not really sure if you'd call it a sync, but there's at least another, value that's rendered on the page, reflected on the page that we can control. And not only is it rendered, right, like it's going to be stored, because if somebody else looks at this clip note, like if I look at the old one, it has the old timestamp. So, this is effectively, if we can get a cross-site scripting payload in here, stored cross-site scripting. So, but first what we want to do is figure out this exact length. I think because I have it set at 50, right? We can just do some basic math. There's two here. There's 48, some buffer that we're hopping over. We need, the 40 to max out the username, and then 1, 2, 3, 4, 5, 6, 7, 8. It would have been really cool if that was perfect. 2, 3, 4, 5, 6, 7, 8. Maybe that's how it works. But anyway, 50 minus these two, that means that this, created thing starts at 48. So we can just go ahead and do the same thing, but instead I'm just going to do 48. And then I'm just going to add a payload to the end of this. So let's just go make another account. And we're going to try a cross-site scripting payload there. Let's just do, we'll do like a script maybe. Yeah, let's just use script alert. Let's just try something like that. See if that works. Come on. And then we'll just go ahead and try and log in with that account. Oh my goodness, I spelled it wrong. How embarrassing. And not only that, that's weird, it didn't overflow that time. What gives? I know that we made this 48 long, right? Huh. Maybe I'm going insane. Let me try and do ALERT. Try that again here. Maybe we have to URL encode it or something. I'm not sure. But let's just try it. Let's see. We'll log out, log back in. Just put something in there. Huh, that's weird. We know that it's 48, or at least to some certainty, we know that it's 48. Maybe 5. Yeah, that should be fine. Am I doing the length correctly? That looks good to me. Interesting. Maybe it's something. Well, I doubt it's something with my payload because it's just sticking it to the username. Huh. That's really strange. Or at least that's something. Okay. Because what I'm thinking is this script thing should be carried over to the next part. Or at least, it should be carried over to the created area. But it's not, which is weird. Yeah, and it's showing that as the author content ID created at. Yeah, it's not overwriting the timestamp anymore, which is weird. Let me try logging us out. And I'll try using a different payload. Let's try something like, I don't know, we'll do like image source is, yeah, let's do like, I don't know, I think, yeah, we'll do on error. So then it's, I think space on error. Oh, I could totally be wrong. On error equals. Yeah, because maybe we don't need to make a new tag. Maybe we're already outside of tags or something. Let's try that. We'll send this, make sure that account gets created. That does not seem to be writing. Oh, wait, interesting. Okay. That kind of worked, right? Image source on error alert 1. It looks like it's kind of working. Let me try like adding a space in here. Maybe it is the spaces that's giving me trouble. Or I need the whole thing. Come on. Let's try it again. We'll log out, log back in. Please. Oh, perfect. Okay. So that payload seems to work just fine. I'm not too sharp about this stuff, so I'm not totally sure why that works, but what I imagine is, it's rendering that on the page, image source, recreate an error. We must be, so it still shows up there, but the image that we created, it gets rendered on the page right there. I'm not totally sure. What I want to do is see if we can kind of do what we did on the last video where we called out to our own machine. So let's just try and let me see. I think I've already got some stuff here. Let me do cat. Yeah, so what's this gonna do? This is gonna take my log administration. Oh, okay. We're gonna kind of skip some steps here. Basically, there's local file read that you can do, and you can use that to figure out that there's an administration page that we can gain access to. But what we're gonna do first, I think, is we'll just try to call out to our own JavaScript. So let's just do Python 3, or let's do this. I think I have to do it on a non-standard port because that's just gonna make it easier. Let's do it on port 9000. And instead of having it trigger an alert, let's have this do, let's see, we'll do on error equals, we'll do, I think import, I've got this written down in my notes here. Port 9000. I think we need a semicolon here. I think that's okay. And then I hope that's not like a, okay. We need a space that just looks like it's making a new line. We'll make sure that that account gets created. Log out. Log in. Shouldn't even be correcting that. Okay, so it executes that JavaScript. You can kind of see in the background here. It got gape.js, but it didn't actually finish executing it. And what it should be doing is sending this log information to us, but it's not. The reason for this, I think we can actually figure out by just looking at our browser here. I think it's going to be in the console. Yeah, you can see it right here. Cross origin request blocked. Same origin policy allows or disallows reading remote resources at gabe.js. Reason the course header access control allow origin is missing. So here's the important thing. Like, it doesn't tell us that, you know, what this access control allow origin header is. It doesn't tell us exactly what it's looking for, but it tells us that it's missing, which is kind of interesting in the sense that, like, you know, why would they tell us that? But not only that, it's like, you know, this information is useful because if you're trying to do your own, you know, scripts or whatever, and you're seeing that they're not bouncing back, you can add this to your methodology. This is a new place to look. But anyway, all we're really going to try and do is we can do like learn more maybe, and this will show us like Mozilla's page for it. And this is kind of the same thing, but you can configure a site to allow access by using the star wildcard or asterisk. Only use this for public APIs. This is really, really pointing us towards like, hey, maybe try like using the, you know, the wildcard for this. So what we've done here is if you ask ChatGPT or any of, you know, the latest and greatest whatever language models, you can get a pretty straightforward script like this. So this is just going to host a simple HTTP server. The only difference being is that it's going to serve it on port 9000, and it's got this access control allow origin wildcard header that it's going to be serving. So I'm just going to do Python 3 server.py, and it should be hosting just fine. Cool. We'll talk about shell.js in a second, but now let's see if this works. So we can go ahead and I think we can just refresh this page. And cross origin request blocked. Course header allow origin header missing. I wonder why that is. Maybe I need to go back and go forward. Refresh something. It's still not reaching out to this. Oh, you know what? I might not have edited that code from when I messed with it earlier. 10.10.14. No, that's my IP address right now. That should be okay. What about... That's fine. What about this? Those all look okay to me. I wonder what might be happening. Let me think. Not totally sure what's going on. Let me think here. 9,000. Pretty sure that's working okay. Let me try. We're going to try just making this account again and logging in. We'll try it one more time. Let's see. We'll log out, log back in. Okay. We saw some stuff happening back here. I know this looks like a lot. Here's the thing. It gets gabe.js, which then base64 encodes I'm pretty sure it's just the page content into a base64 here. So I'll just find a website to do this for me. Here we go. And you can see the contents of the page. You can see the authenticity token of the user that's hosted. In this case, it's us, right? This is what ours should be. And that's because we're the ones executing our own payload. The cool thing, though, is that, like we saw earlier, we can use like the report functionality. So, I think my payload that I have set up here, it should be trying to get this administration page. And of course, we don't have access to some administration page. But the person who does have access to that administration page is the administrator. So we can just report this page. And then hopefully, in the next minute or so, the admin will have a look at it. Some, automated process will click on that page and it'll send us some more data that we can work with. In that case, we might actually find, I guess, more information, maybe. Let's see. The post action. Maybe I need a timestamp on this. Yeah, what's that? 2302? Okay. We just do. I'll just open that again. And I'll send that request a couple more times. Hopefully that works out for us. If not the end of the world. But what we're trying to do is at least get that administration endpoint kind of thing going. The reason we know about that administration endpoint is if you used a report for one of the earlier requests that just outputs the base64 encoded content of the file, you'll see that in the headers, the administrator has access to an administrator portal that's linked on his page, and we don't have access to that. So when the admin views this, our cross-site scripting payload goes through, it executes the JavaScript that we're hosting, in which case it bypasses the cross-origin resource sharing protection header or the access control allow origin header by submitting a wildcard, and then it sends us the base64 encoded contents of the page back. It looks like the administrator clicked on it, and now we can see this. So let's go ahead and base64 decode this. So go ahead and paste it. And you can see this authenticity token is different from ours. So there's something we could use if we want to do some forgery for the administrator. I think there's probably more information here, but the authenticity token is the big one. You can see post, administration, reports, authenticity token value, autocomplete off. So, okay, now we've got information about how we can actually start viewing or how we can send post requests to... Okay, these are the different report logs that he's viewing on that page. You can also see which JavaScript libraries are being used, other things. So what's the point of this? I mean, what we're doing is we're just reading data as this user, and you can take this machine further and further and, execute these commands as this person. And you can kind of see the remnants of one I did, because I think I still have a shell.js somewhere. So you can use you have to find some SQL injection stuff to actually read the content of this file, and then you can find some command injection vulnerability stuff, if I remember right. But either way, we just went through the cross-origin resource sharing part of the machine where we just spoofed that header, or not spoofed it, but just noticed that we could use that header because of what we saw in the behavior. So kind of short, and it's really closely linked to cross-site scripting and other, browser-ish, browser attacks. So without any further ado, let's just go ahead. We'll go back and talk about prevention, and then we'll wrap things out. All right. So kind of as we touched on a little bit, most of the issues that come with cross-origin resource sharing, they have to do with misconfigurations. So if a resource contains sensitive info, the origin should, be specified in the ACAO header, the access control allow origin header. Also only allow trusted sites in there. Don't put the wildcard character, because then anybody can see those responses. And also, avoid using wildcard characters in internal networks, because that's not an adequate protection by itself. Don't try to use this as a substitute for also server-side security policies. This is meant to be a browser thing. It's meant to stop your browser from executing code from other sources and from utilizing other origins for that information. So without any further ado, that's kind of all we got to talk about today. It's kind of a smaller one, but still worth talking about. So I'll catch you later.